We tend to call this the square root of 4. In reality, we should be calling this the positive square root of 4 or the principal square root of 4 or radical 4. We'll make more of a big deal about that later, but let's try to get in the habit of doing it. It does mean just get the positive square root of 4, which we know is 2, because 2 squared equals 4. The square root of 9. We know that the square root of 9 is 3, because 3 times 3 is 9. We know that the square root of 16 is 4, because 4 squared is 16. But there's another way that we can look at this. We want to get in the habit of looking at radical 16, maybe another way, just to help us understand the more difficult problems a little bit more. We can write this as two factors that are also radicals. Radical 4, well, in fact, let's do it this way. We can write this as radical 4 times 4, and with radicals, it's okay to make them separate radicals and multiply them together. And then what we can reason is we can say, well, the principal square root of 4 is 2 times the principal square root of 4 is also 2. So 2 times 2 rather is 4. So it's another way to justify that the square root of 16, the radical of 16, is 4. Now, let's look at radical 3. It'll help us when we look at something like this. How much is this worth? Well, it's ugly. If we try to take the positive square root of 3, this is the number that you have to multiply by itself to end up with 3. And it's not even exactly that number. The calculator just cuts it off after 9 digits or whatever. It's irrational. It's a decimal number that goes on and on and on. So how much is radical 3 times radical 3? Well, it's going to be 3. If you multiply these two values together, you're going to get 3. But we can also look at it this way. This equals this, which is this. Now, we look at these different math expressions. How much is that worth? And that one. And that one. They're all worth 5. Even that is worth 5. So in the world of mathematics, we like to simplify things or evaluate things. We don't want to necessarily leave them as an ugly conglomeration of values. So we just say, hey, all this simplifies to 5. So that's what we're going to be doing. We're going to be trying to simplify these radicals. The positive square root of 25 is 5, so let's just learn to write it as 5. Well, then we get to something like this. We want to simplify radical 12. We want to get as many factors of that number outside of the radical sign. So we're going to start by rewriting this using radical factors. Factors are things that are multiplied, and radicals, that's what these are, these positive square root signs. So we could write this as radical 4 times radical 3. That would be equivalent to radical 12. But this guy, the positive square root of 4, is 2. So this means 2 times radical 3. So there we go. We simplified it because instead of having 12 under the radical sign, we only have 3 left under the radical sign. So when working with principal square roots, these guys right here, anytime that you have a pair of radicals with the same radicand. Now the radicand is the number under the radical sign. Like if you see a 9 here, that's the radicand. So anytime you have a pair of radical factors with the same radicand, the result of multiplying them will be the radicand. What the heck are we talking about? Well, it's what we just got done looking at a moment ago. If you take radical 3 times radical 3, you have a pair of radicals with the same radicand, the same number under the radical sign. So ultimately what you get when you multiply these two together is whatever the radicand was. So you get 3. Again, because this is radical 9 and the square root of 9 is 3. So that's an important idea, principle that we're going to use here. If you have a pair of the same radicals, they have the same radicand, then when you multiply them together, your result will just be that radicand with no radical sign left. Okay, so we want to simplify this. We're going to simplify it 2 ways. We're going to say, well, let's rewrite this. I know I can get to 18 by multiplying 9 times 2. So this would be equivalent to that. The nice thing about writing a 9 as one of the factors is that's a perfect square. The radical of 9 is 3. The positive square root of 9 is 3. So it's 3 times radical 2. So that would be simplified. That's one way to get it. But there's another way to get it. We can say, okay, now wait a minute. Radical 18, we could write this as radical 6 times radical 3. That also equals 18. But right now we seem to be stuck because neither one of these is a perfect square. That's irrational and this is an irrational number. They're ugly decimals. But hold the phone. We could break this guy down even further. Radical 6 could be written as radical 2 times radical 3. So we could say, oh, this can be written this way, and then we multiply by that radical 3 over there. Now we go back to the principle we just got done looking at, right here. When we have a pair of radicals with the same radicand, look, we do. We have two radical 3's. So it must be that this radical 3 times this radical 3 will just give us 3. And then we have radical 2 times 3, so there's our final answer. Usually we write the factors that aren't radicals in front. So we would also arrive at our simplified destination. 3 radical 2 would be the way to simplify that. Now it's always nicer if we can find perfect squares as factors of that and go right there. And the stronger we are in our understanding of number sets, the more likely you are or we are to go to better factors. But hey, if you choose 6 and 3, just keep breaking them down to smaller and smaller radical factors. Any pair with the same radicand will just give you the radicand for the final answer. So we simplify this. Now, let's do this again. We can say, okay, I'm going to write this as 2 factors. We could make this radical 6 times radical 8. Let's see, those don't have the common, they don't match, but let's break this down. Radical 6 could be written as radical 2 times radical 3, and then we can write radical 8 as radical 2 times radical 2 times radical 2. And then every time we have a pair of the same radical with the same radicand, then this times this is going to give us the radicand. Because again, remember, radical 2 times radical 2 would give us radical 4, and the positive square root of that is 2. A pair of the same radicals, it gives you that result. We have another pair of radical 2's. So radical 2 times radical 2 would also give us 2. And then we have a radical 3 that's kind of stranded. So, and we tend to put that at the end, but we can put it here. So in the end, let's clean this up. We have 2 times 2, which is 4, times a radical 3. So this would be the simplified version of radical 48. Now, in similar fashion, here's what a lot of us as math teachers teach our kids. We do factor trees. So we say, all right, you guys, just keep finding all the factors of the number 48, all the numbers that multiply to 48, until you get it down to where we have prime factors. You can't divide 2 anymore because it's only divisible by 2 or 1. That's prime, that's prime. 8 can be written as 4 times 2. That's a prime. 4 can be written as 2 times 2. So in the end, we say, well, you know what? The prime factorization of 48 is that we have a 2 times a 3 times a 2 times a 2 times a 2. Multiply all those prime factors together and you'll get 48. So we use factor trees to help us identify what this simplified radical is going to look like. And from here we say, well, you know, just like before, we have 2 2's, so that becomes a 2, and 2 2's here, so that becomes a 2, and this 3 stays under the radical sign. But hold the phone. Was that a little bit confusing? I think it might be. Because when we just factor 48 and then we're left with those numbers, we may lose sight of the fact that all these numbers are really under the radical sign. So what I would prefer to see is if we're going to make a factor tree, let's take the extra step to say, okay, this is radical 48, and it can be the product of radical 6 times radical 8. Radical 6 becomes radical 2 times radical 3. Radical 8 becomes radical 4 times radical 2. Radical 4 becomes radical 2 times radical 2. Now this makes more sense because we have 2 radical 2's multiplied together. A pair of radicals with the same radicand will become just what that radicand is. So those guys are taken care of. We have another pair of radicals. Radical 2 times radical 2 is also 2, and there's a radical 3 that's left. So if we do a factor tree, I think at least initially, until we're really straight on what it is that we're finding, I think it would be good to keep writing radicals all the way through that tree. So we're almost done. Let's try these 2 and then we're good. we want to simplify this. Now this could become 2 times 5, but let's do this. Do we see that factor in the 40? And indeed we do. So let's leave this as a radical 10. Let's rewrite this guy as radical 10 times radical 4. There's your radical 10 and there's your radical 40. So we don't have to go all the way down to the prime factors. Anytime we find 2 pairs of the same radical, whatever the radicand is, that's what the result is. Radical 10 times radical 10 is 10. Because radical 10 times radical 10 would be radical 100. The square root of 100 is 10. And we know that radical 4 is going to be 2. So in the end, this is 10 times 2. So this is 20. That's our final answer there. Nothing left under a radical sign. Now when we get to something like this, it's not as nice. 6 doesn't go into 40, so you know what? Let's break them both down. 6 is going to become radical 2 times radical 3. 40 we could write as radical 4 times radical 10. These guys are all as simple, well, these two are as simple as we can get it. This guy's not. Radical 4 can become 2. So we have radical 2 times radical 3. This radical 4 right here just became a 2, so times 2. And then let's rewrite radical 10 as the product of radical 2 times radical 5. So in factoring it down even more, we now see that, oh, yippee skippy, we got a radical 2 and a radical 2. 2 pairs of the same radical. When you multiply them together, you're going to get whatever was inside, you're going to get the 2. So very carefully, then in blue, these 2 guys become a 2. We still have this radical 3. We still have this 2, and we still have a radical 5. So now we clean them up. Now, this is 2 and this is 2, but this is not 3. This is the principal square root of 3. So that's a different animal. And that's not 5, that's the square root of 5. So let's just multiply the like things together. So the 2 times the 2 is going to give us a 4, and radical 3 times radical 5 will give us radical 15. And there you go. That's as simple as we can get that puppy right there.